So let's try a couple of examples. In 46 and 47, we're going to be doing the opposite of what we did in our definitions. Taking this number line and expressing its answer in interval notation. So the first thing that I'm going to write down is the bracket with the -5. And because this number line is shaded to the right, I'm going to say that my answer includes the -5 and anything to the right of that all the way up to infinity. In problem 47, I'm starting at -infinity, and my answer includes everything up to a +2. But because the 2 has a parenthesis instead of a hard bracket, I'm going to also write that parenthesis in my interval notation. That's the symbol that tells me that 2 is not actually included in my answer. Now let's try to do a few here where we go from the algebraic answer to the graph and then also give the interval notation answer. So in 48, I'm saying that t has to be something that is larger or equal to 3. So I come down here in my number line, pick a place for 0, show that 3 is somewhere to the right of that. Since 3 is included in my answer, I'm going to make a hard bracket, and t needs to be larger than 3, so I'm shading this direction. When I go to write that answer in interval notation, I have a +3 in the bracket going all the way up to infinity. In this next example, I'm saying that x needs to be something bigger than 1/2. So I'll find 1/2 on my number line, pick a 0. 1/2 is going to be somewhere to the left of that. X has to be bigger than 1/2, and it can't include the 1/2. So the parenthesis is the soft one, not the bracket, and x is bigger than 1/2, so the shading again is going to go that direction. And when I write my answer in interval notation, I have a parenthesis with 1/2, comma, the infinity sign, and the closed parenthesis. Now let's try one that has a little algebra in it. In problem 50, we're looking at an equation that looks very much like the algebraic ones we've already solved. I'm going to put the line down the middle of my inequality, just like I have before, and use the same algebraic steps that I've used in all of the previous sections of this chapter. Distributive property first gives me 10 minus 15h plus 9h. Instead of the equal sign, I'm drawing the less than or equal sign, and the distributive property on the other side gives me 2h plus 2. Then I'll combine like terms. 10 minus 6h is less than or equal to 2h plus 2. I'll gather all my like terms on one side by taking 2 h's away from each side. That gives me a 10 minus 8h less than or equal to 2. And then taking 10 away from both sides, I get negative 8h is less than or equal to a negative 8. Now here is the only place in the process where the rules are different for inequalities. If you multiply or divide by a negative, the inequality changes direction. Okay, so in this case, I'm going to need to divide through by a negative 8, and because I'm dividing by negative 8, not positive 8, my inequality is going to turn around this direction. And so it's been a less than or equal to all the way along. Now it's going to become a greater than or equal to. And negative 8 divided by negative 8 is a positive 1. Putting this problem onto my number line, now it looks like the ones that we worked with up here with 48 and 49. So I'm going to use the same process. I'll locate a 0. 1 is somewhere to the right of that. H has to be things that are bigger than 1, but it can include 1. So my bracket's going to go that direction. My shading's going to go that direction. And when I write my answer in interval notation, the interval notation is going to say, oops, hard bracket and a 1 all the way up to infinity. Checking inequalities looks just a little different from the way we checked equations as well, because we need to check the answer to make sure that it makes the equal part true, but then we also need to check something on the left and the right sides to make sure that values on this side of the number line don't work as a solution, but that numbers over here do. Okay? So the first thing that I'm going to check is the value 1 to make sure that when I put 1 in for h, it does make these two sides equal. So checking 1, I have 10, oops, nope, I have 5 with the distributive property. 2 minus 3 times 1 plus 9 times 1 should be less than or equal to 2 times 1 plus 1. And in this case, I'm working on just the equal part, making sure that these two sides are equal. So 3 times 1 is 3, 2 minus 3 is a negative 1, negative 1 times 5 gives me a negative 5, and the 9 times 1 is going to be a plus 9, giving me a positive 4 on the left. Checking it over here on the right, 1 plus 1 is 2, and when I multiply it by 2, I do get 4. So that part checks out. I'm then going to check my answer for a value on the left. 0 looks like it would be an easy one to check. So let's try that with 0. 5, and this time I'm checking 0. 5 times 2 minus 3 times 0 plus 9 times 0 is supposed to be, and this time I'm focusing on the less than part. Or actually not supposed to be less than, because it's not part of our answer, so we're hoping that it's not going to be less than 2 times 0 plus 1. Let's see if that's true. Well, 3 times 0 gives me 0, so that's just going to be a 2, which when I multiply it by 5 is 10, and 9 times 0 goes away. So I'm hoping that this 10 will not be smaller than what I get on the other side. And 0 plus 1 is 1, times 2 gives me 2. Sure enough, 10 is not smaller than 2, and it wasn't supposed to be, since it's not shaded in my answer, so that part checks out. My final check is for some number that lies to the right of 1. I'm going to choose to check 2, just because it's another small number. You can really check any number over here on the left that you want to. I'm going to check 2 so that my arithmetic stays small. So I'm going to have 5, 2 minus 3 times 2, plus 9 times 2 is less than or equal to 2 times 2 plus 1. Okay. 3 times 2 gives me a negative 6, and when I subtract 2, or 2 minus 6, I'm going to get a negative 4, which when I multiply it by 5 gives me a negative 20. And 9 times 2 is an 18, so that gives me negative 2 on the left side. Checking it on the right side, and my goal is to have this be true, to have it be smaller on the left than it is on the right. Well, 2 plus 1 is 3, times 2 is 6. Sure enough, when I put in 2, it does come out to be true, because negative 2 is smaller than 6. So my answer checks out.